Aaron was asked to find if f of x is equal to x squared minus 1 to the 2/3 power has a relative maximum. This is her solution. And then they give us her steps, and at the end they say, is Aaron's work correct? If not, what's her mistake? So pause this video and see if you can figure it out yourself. Is Aaron correct, or did she make a mistake, and where was that mistake? All right, now let's just do it together. So she says that this is the derivative. I'm just going to reevaluate it here to the right of her work. So let's see, f prime of x is just going to be the chain rule. I'm going to take the derivative of the outside with respect to the inside. So this is going to be 2/3 times x squared minus 1 to the 2/3 minus 1, so to the negative 1/3 power, times the derivative of the inside with respect to x. So the derivative of x squared minus 1 with respect to x is 2x. There's a fire hydrant, fire, not a hydrant, that would be a noisy hydrant. There's a fire truck outside. But okay, I think it's passed. But this looks like what she got for the derivative, because if you multiply 2 times 2x, you do indeed get 4x. You have this 3 right over here in the denominator, and x squared minus 1 to the negative 1/3, that's the same thing as x squared minus 1 to the 1/3 in the denominator, which is the same thing as the cube root of x squared minus 1. So all of this is looking good. That is indeed the derivative. Step 2, the critical point is x equals 0. So let's see. A critical point is where our first derivative is either equal to 0 or it is undefined. And so it does indeed seem that f prime of 0 is going to be 4 times 0. It's going to be 0 over 3 times the cube root of 0 minus 1 of negative 1. And so this is 3 times negative 1, or 0 over negative 3. So this is indeed equal to 0. So this is true. A critical point is at x equals 0. But a question is this the only critical point? Well, a critical point, as we mentioned, is where a function equals 0 or where it is undefined. And this is the only one where the function equals 0. But can you find some x values where the function is undefined? Well, what if we make the derivative, what would make the denominator of the derivative equal to 0? Well, if x squared minus 1 is equal to 0, you take the cube root of 0, you're going to get 0 in the denominator. So what would make x squared minus 1 equal to 0? Well, x is equal to plus or minus 1. These are also critical points because they make f prime of x undefined. So I'm not feeling good about step 2. It is true that a critical point is x equals 0, but it is not the only critical point. So I would put that there. And the reason why it's important, you might say, well, what's the harm in not noticing these other critical points? She identified one. Maybe this is the relative maximum point. But as we talk about in other videos, in order to use the first derivative test, so to speak, and find this place where the first derivative is 0, in order to test whether it is a maximum or a minimum point, is you have to sample values on either side of it to make sure that you have a change in sign of the derivative. But you have to make sure that when you test on either side that you're not going beyond another critical point, because critical points are places where you can change direction. And so let's see what she does in step 3 right over here. Well, it is indeed in step 3 that she's trying to test values on either side of the critical point the one critical point that she identified. But the problem here, the reason why this is a little shady, is this is beyond another critical point that is less than 0, and this is greater than another critical point that is greater than 0. This is larger than the critical point 1, and this is less than the critical point negative 1. What she should have tried is x equals 0.5 and x equals negative 0.5. So this is what she should have done, is try maybe negative 2, negative 1, negative 1/2, 0, 1/2, and then 1 we know is undefined, and then positive 2. Because this is a candidate extremum, this is a candidate extremum, and this is a candidate extremum right over here. And so you want to see in which of these situations you have a sign change of the derivative, and you just want to test in the intervals between the extremum points. So I would say that really the main mistake she made is at step 2 is not identifying all of the critical points.